HTTP, Hypertext Transfer Protocol, is an application protocol. Hypertext is structured text that uses logical links between nodes containing text. HTTP is the protocol to exchange or transfer hypertext. HTTP is a stateless protocol. That means no information is retained by either sender or receiver. HTTP functions as a request-response protocol in the client-server computing model. A web browser, for example, may be the client, and an application running on a computer hosting a website may be the server. The client submits an HTTP request message to the server. The server, which provides resources such as HTML files and other content, returns a response message to the client. The response contains completion status information about the request and may also contain requested content in its message body. The most used HTTP request is GET. A GET request is designed to request server resources. With these types of requests, the parameters are sent to the server inside the URL. You see two different HTML elements which will cause GET requests. POST request is designed to request server resources as well as GET requests. But unlike GET requests, parameters are sent to the server inside the body of the request instead of the URL. It's still possible to send the parameters inside the URL, but if you use POST request, you should prefer sending parameters inside the body to URL. In this slide, you see the HTML elements to send a POST request. What's that, you ask? What's the advantage of sending parameters inside the body instead of URL? Good question. Almost always, the traffic between the server and the client is logged on the server side. Such log files usually contain the URL. If you send the parameters in URL, they are saved as clear text in your log files. So anyone who can see the log files can also see your sensitive parameters. You should use POST requests to send sensitive data, but please make a note that it's not enough for the privacy of the traffic, because any man in the middle who listens to the network will see the parameters, even though they're inside the body of the request message. So you should encrypt your traffic. The server, which provides resources such as HTML files and other content, returns a response message to the client. The response contains completion status information about the request and may also contain requested content in its message body. Every response has 3-digit response status codes. Responses with a code starting with 1 are informational responses. An informational response indicates that the request was received and understood. It is issued on a provisional basis, while request processing continues. It alerts the client to wait for a final response. The message consists only of the status line and optional header fields, and is terminated by an empty line. Responses with a code starting with 2 mean success. This class of status code indicates the action requested by the client was received, understood, accepted, and processed successfully. Responses with a code starting with 3 mean redirection. This class of status code indicates the client must take additional action to complete the request. Many of these status codes are used in URL redirection. A response with the code starting with 4 shows that there is an error that seems to have been caused by the client. For example, if the requested resource is not found on the server, you get a 4XX coded response. 5XX coded responses mean that the server failed to fulfill an apparently valid request. HTTPS consists of communication over HTTP within a connection encrypted by TLS, Transport Layer Security, or its predecessor, SSL, Secure Sockets Layer. The main motivation for HTTPS is authentication of the visited website and protection of the privacy and integrity of the exchanged data. There are a few questions we should ask about using SSL or TLS. Does the application have a version working without SSL? If it has, the user might be tricked to connect over HTTP, or an attacker can perform an SSL strip attack to turn an HTTPS connection into an HTTP connection. Which versions of SSL or TLS are allowed by the server? The older versions of SSL and TLS have weaknesses, so it's not safe to use them. Has the certificate of the application been signed by a valid certificate authority? Which algorithms are used for encryption, and are they strong enough? There are tools such as SSL Scan and SSL Digger to test the SSL or TLS configuration of the server. You can find the tools in Kali Linux. In addition, there are some browser plugins to analyze the SSL or TLS of the application. You can try Calamel or Komodo SSL plugins for Firefox. So even though it might seem a bit off topic, we can quickly see how a typical encrypted connection between the server and the client is established. The client sends the information that the server needs to communicate with the client using SSL. This information contains a client's SSL version number, cipher settings, session-specific data. The server sends the information that the client needs to communicate with the server over SSL. The server also sends its own certificate. The client uses the information sent by the server to authenticate the server. Using all data generated in the handshake thus far, the client creates the pre-master secret for the session, encrypts it with the server's public key, and then sends the encrypted pre-master secret to the server. The server uses its private key to decrypt the pre-master secret, and both the client and the server perform a series of steps to generate the master secret. Then they use the master secret to generate the session keys, which are symmetric keys used to encrypt and decrypt information exchanged during the SSL session and to verify its integrity. The client then sends a separate message indicating that the client portion of the handshake is finished. The server sends a separate message indicating that the server portion of the handshake is finished.